Okay, so today I'm going to walk through the assembly of one of these. This is a robot that I've designed to shoot HDRI spheres for 3D and visual effects lighting for filmmaking. Yeah, as you can see, it uses a standard Canon camera. Everything is controlled through the robot. The power comes from the robot. We meter the light to set up the camera. The robot controls the camera via USB. And the point of all this was to build a tool that could be used on a film set to speed up and make more reliable the creation of HDRI spheres. And hopefully in a way that people would actually start to use this more. The intention originally is for my work. However, I've had a couple of friends that work in the filmmaking industry also ask to use this. So I've built a couple of extras, and we're going to walk through the assembly of one of those today. Okay, so this first part is, it's not tricky to assemble, but it is tricky to remember the order that things have to go together in. This first part is, I think, the only part that's super critical, the exact order everything comes together. So try to get through this in one try. We'll start with the base. It's just this is nylon with a 3/8 inch threaded insert, so it can attach to a tripod here. And there's a lot of parts in this first few steps that the orientation matters, which direction they're facing and which order they go together. So let's give it a shot and start with this piece, which is the tower for the wires to go through, so all the USB control can get up to the camera from the robot. And since it's in the middle, this is generally the place you need to start. And this slot needs to be aligned facing this direction. This is where the circuit board will end up going that controls all of this. And so we'll start by putting these pieces in. And we're just using, I believe these are M4 screws that thread into these brass inserts that I've melted into this nylon part. And all these parts are 3D printed or purchased from Amazon or a couple of electronic suppliers online. The parts, the 3D files, I will make available. I'll add a link somewhere where you can find them on probably Thingiverse. I'll also include the electrical schematics and the PCB board design for all of this. So if you want to make one of these, you're more than welcome to. And if you do that and you need help, let me know. I would love to help a couple other people try to build one of these. It would be really interesting to get some feedback because this design is far from perfect. Okay, so the slip ring tower is installed to the base, and now we're going to install the slip ring wiring harness. And so what this is, slip ring is a component that allows wires to rotate. And so you can see this little cylinder here. We've got a bunch of wires coming in and a bunch of wires coming out, and we can spin this around basically forever. The wires maintain their connection and they never break. So we'll put this in here and route these wires into this tower, and we'll add this zip tie to keep the wires from ever being able to work their way out of here and bind up inside of the bearings and other rotating axles that will mate to this part in a few more steps. Okay, so slip ring tower is installed. A couple of important things that need to happen now that I usually overlook or forget at this point are these two pieces. This is a nut with a taper on it that mates to this bearing, and this is a jam nut that locks onto here. These are both just printed out of nylon. It's not super ideal, but I don't have any way to make metal parts. If I did these parts that go onto the main axle, which we'll see in a little bit, I would have preferred to make out of aluminum. It's just an area where there's a little bit more strength needed than I can actually get out of the 3D printed parts, but with nylon everything kind of worked out okay. Alright, so now that these are installed, well, resting so we can install them, we'll push it aside and we'll put these things onto the bearing carriers. There's 2 bearing carriers. I've already pressed this bearing in. It should pop out pretty easy, but it's just a bicycle bearing from handlebars of a bicycle. And it's just pressed into this plastic piece with these brass threaded inserts melted in. And these parts are these legs that hold these bearings apart. These 2 are identical. These are a left and a right because there's a groove in here for the drive belt to pass through, which we'll install in just a minute. This one is the bottom bearing carrier, so we'll put it in the bottom facing down. And we'll start to screw these in. And these 2 that have the notch, it's really important that they face each other so the notch allows for the belt to come out. So this left and this right are the orientation really matters here. Otherwise the belt will rub and the robot will not work. Okay, so we'll do these 2 bottom ones, then we'll put the top bearing carrier in. There's no bearing in it, which I'll explain in a later step. So a little bit of an issue with the 3D model that will make more sense in a little bit. And tighten, 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 tighten. I'm not going to tighten these all the way yet. I want these parts to be able to kind of wiggle around a little bit for when we place this here. So before we get any further, we need to put this drive gear and this drive belt into this part and make sure that the belt pokes out between these 2. And you can see why those slots are there to allow this belt to stick out without rubbing on these pieces. This is just going to float in here for now. We will attach it to the axle after we install the axle later. So, more screws. Okay, now this is the main part that carries all the rotational forces and holds the camera up while it spins around. And it needs to face, the belt sticking out needs to face this smaller end of the base. It also needs this wire to come through the middle of it, and it needs to not pinch these wires. So we will feed this wire up. Get these nuts a little bit out of the way, make sure that we're not pinching these, and that's where it goes. So we'll get one of the screws and start twisting. one more. Oops. Okay, back. Okay, there is the slip ring tower and the bearing carrying tower. Next, I think we will install the stepper motor. For that, we will need a stepper motor and this part, which holds the stepper motor here and allows us to adjust it. So I'll get these screws out of here. There's so many screws I had to thread them into where they belonged, otherwise I would not remember which screws went where. And this piece has some nuts pressed in here, and then some nuts pressed into the bottom, and then some nuts into these little channels here for tightening everything down. And it just sits in here kind of like this, and the stepper motor, it's actually threaded. Weave this through some of these parts. It needs to get to the other side of the robot to plug into the computer. And so, we'll get that work through there. And put this back in place. And these screws are way overkill. Way bigger than they need to be. I probably actually don't even need them in here, but there's a place for them. And doesn't hurt anything, just makes it a little bit heavier, which isn't always bad when you're trying to spin a camera around and take a bunch of pictures really quickly. So we will wait to tighten these all the way as well until we get all the fasteners in place. Okay, so the stepper motor just pops in there, and the next two fasteners we want to put in go in here and here, and we can tighten those in. Lost one of the nuts. Back right there. Okay, so now the stepper motor is in there, the mounting is mostly secured. We can now go ahead and tighten these really large fasteners here. Okay, one more. There we go. Alright, so the next piece is this, and this just sits on top of the stepper motor, and this will allow us to adjust the belt tension. These 4 screws thread into the gearbox on the stepper, and then 4 more will thread into this tower. Let's go ahead and get these in. Before I tighten all these, I want to get them all started, and part of that's because when I tighten these, it actually sandwiches the stepper motor between this little hat and this tower, so I get some clamping force from these as well as these. If I tighten these up now, I won't be able to adjust the tension. Okay, so we can still move it, but there's a little bit of friction which will help us out. Now we need the drive gear for the stepper motor, and on the shaft there's a flat, and then there's 2 set screws, so we just need to align one of the set screws with the flat. And I am not going to tighten these too much because I need to pull this in, get the belt around it, and then I'm just going to pull it back. And this doesn't need a ton of tension on it. Actually, we can't tension that yet because we need the axle in here. So we're actually going to leave this out, leave this loose. Forgot about that. Trying to tension this gear against nothing, that's kind of silly. So now the stepper motor is installed. We have the stepper motor wire routed over here where the printed circuit board will go. One of the next things we can install will be the battery. And this is just a 7.4 volt, 2200 milliamp hour lithium battery. And I've extended the lead here so that it can route through the robot, and we'll plug the built-in charger into the charging plug. It sits into this little slot, and we have this nylon piece which serves to clamp it in there and also kind of protect it so that it's extra hard to puncture this in case somebody drops this, or I don't know, any kind of damage can be avoided, hopefully, by shielding it with that. A little bit of armor, I guess. And for the battery, this clamp mounts onto this adapter. So we're going to screw this adapter in. Whoop. Screw this adapter into this tower. Okay, the battery in, the little shield in, and this top screw aligns with the piece in the middle there, and these. This part's a little shorter than the battery, so as we tighten these, it actually sandwiches the battery in this way, and then when we tighten this one, it sandwiches it in against the robot this way, so it can't really vibrate or move around in there. And these long screws are just going into some nuts that I pressed into the nylon there. And then, there. Now the battery is protected and can't move around. Okay, so next piece we can install will be over here. This is a home switch. It's basically a little micro switch that runs, well, it sits still and a cam comes around and triggers it so that the robot can tell where its home position is. And this is the switch with the little roller on the top and just triggers like that. And this is the mount for it. So you can see now, like, where we have the gear, it's starting to get really covered up, which is why it's super important the order that we installed all these things in. Otherwise, you wouldn't be able to get the pieces in now. And there's a step coming up that I may have to remove the battery for that involves tightening these nuts down, and it's very hard to reach them to get them tight. So we'll see. Sometimes it goes smoothly, sometimes it doesn't. Okay. So this little plate goes on here, and this allows us to adjust the home position switch up and down so that it triggers properly on the cam that we'll see in a little bit. And it just attaches with these two screws here, and I'm going to set it kind of low, and then we'll raise it up later until it fits. Oops. Nope, I got this upside down. Flip that over so that our threaded inserts are down at the bottom here. Should have probably designed this part to be symmetrical, but it didn't occur to me when I was doing all the modeling. Okay. Hopefully we don't have to flip that back around, but now we can put these in. And I don't want this tight, I want this to be able to move around so we can adjust it after everything is together. Okay. Next we can put the switch on. These we can tighten. Okay. And this wire also passes through here and comes out over here. So there's our home switch. Okay, so far so good. I think the next thing we want to do is actually to put this main axle in. So this is the part that carries all of the load from the camera, and this is where the second bearing is. Because it fits so tight on here, I don't want to pull it off. I'd have to pry pretty hard. So this bearing is kind of permanently on here. But this piece, there's threaded holes here, and that's where the drive gear will slip around here and lock in with some screws. And a circuit board will mount here, and the arm that the camera rotates on will mount on here. And these fasteners here, this took me a while to get right, but these are very long, I don't know, 2-inch long screws that thread down through this nylon and come all the way down to about here. I was having some issues with rigidity. When the camera would rotate, this plate would kind of flex around. These 8 screws here helped a lot with that. And just to add a little bit more support, I've added 4 screws as far away from this diameter as I could that kind of pinch this part to here. Don't know that they help, but this part was flexing so much, every little thing I could do I wanted to try. And I also switched to this different type of nylon, which turned out way better than the first nylon that I tried it on. So this actually doesn't really flex a whole lot, and it's super strong. So what we need to do is get this plug up through this hole and sticking out the top, and then push this down in here. And to do that, we kind of need this to be as narrow as possible. And, oh, I'm sorry, forgot one thing. Let me take that out. This stuff's always really fiddly when you're assembling it. What I need to do is get the slip ring back up to the top. I've managed to push it down a little bit. There we go. Okay. So I'll tighten these. Down. Tighten this other one. Okay. So now, try this again. Push that through there. Then this needs to line up with the gear that we put in there. And there. You can see this is a little too high, so we're going to lower it down so we don't accidentally damage it while we tighten some things up. Okay, so there's our main axle kind of installed. Now we need to get these 2 nuts, the bearing nut and the jam nut, threaded on. This is really fiddly, so bear with me while I manage to hopefully get all these things to thread on. And these threads are just 3D printed into nylon, so they're not super amazing, but they seem to work pretty well. Okay. Alright, I got the bearing one installed, so I can just hold this still with my thumb and just crank this down. There's a fair bit of friction because I've modeled these to fit a little tighter than they would if they were metal, just because I was worried about the strength. I should have made these bigger threads, not like a standard metric size like I did. Okay, so there's the nut that clamps in the bearing. So we've just tightened this down and it's pushing those 2 bicycle bearings together and kind of putting this into tension. Now I just need the jam nut to go on. Slug that down. Okay. That went a little smoother than it normally does, believe it or not. Yeah, so I think the next thing we want to probably do is put on the circuit board mount. So this piece holds on the printed circuit board. Let's see, these wires all run out through this slot, and this wire goes underneath here. Yeah, so let's get this little thing bolted in. Okay, so now we have all of our plugs in the right spot and the circuit board mounted, or the circuit board mounted. Let's get these screws off of here and bolt the board in. Washers back. Okay, so this is the printed circuit board that we've designed for this, and let me do a little bit of a close-up here so you can see a little better. These two are just Arduino Mini 3.3 volts. This is the stepper motor controller. This is an Adafruit power switch. And then these two components standing up vertically here, the one on the left is a 9-volt voltage regulator. The one on the right is 3.3. It's set variable, but it's set to 3.3. And we have 7.4 coming in from the battery. And the 7.4 coming in from the battery worked out really well because the Canon cameras also use 7.4 volts, so I'm able to route power basically through this up and power the camera, so you don't need a separate battery for the camera if you don't want it. Yeah, and then having 3.3 volts works out well for powering things like LEDs and whatnot, and then 9 volts drives the stepper driver here. And then these are the connectors for everything, and so this top one is for the USB that goes to the camera. The one next to it is the OLED display that we'll see when it's done. All these connectors go to the user interface panel for the buttons and the beeper and LED and that stuff. This one is for the lux meter that's up in the camera arm, and this is the home switch, and this is where we get power to run up to the camera. See these two yellow wires going to the circuit board are to get the SDA and SCL. These are like a communications bus on the Arduino. I couldn't pass these two connectors down through the PCB because this board underneath the Arduino here is a USB board, and it doesn't have these connectors, so I couldn't go directly down into the board. I had to kind of make these ugly jumpers coming out. Yeah, and we've got this little red jumper here. I can pull this off while I set the voltage on this variable voltage regulator, so that if this comes from the factory cranked up to like 12 or so volts, we don't fry these Arduinos. We install this, set it to 3.3 volts, and then install this jumper to get the current path. Yeah, so let's go ahead and install this. Okay, this is super simple. This just sits on here and the screws go in. and I should have mentioned, this circuit board was designed custom for this project, as were the other two that you'll see. And these designs are all open source. I'm not an electrical engineer. I've never designed a printed circuit board before this project. So I'm sure there is a ton of room for improvement, and would be probably unlikely, but I would be extremely happy if somebody else decided to make one of these and had some suggestions for improving this. There's a few things I would like to change in the design, but I'm not going to make another version until I have a more substantial improvement to make. So yeah, feel free to send me feedback about all the really bad decisions I made when I was laying this out. It is a 4-layer board. It didn't really need to be. I just wanted to do that, to do a 4-layer board, just to do it, because it seemed fun. You could definitely lay this out on a 2-layer board. The 4-layer board was fun because it let me have like a ground plane and then 2 different voltage planes. So I've got one layer is like got the 9 volt and one's got the 3.3 volt, and then the top layer is just for data. So we've got the high voltage, 3 and 9 volts on the bottom, then a ground plane, and then all the data layer on top. Maybe that's not the best way to do it, but in my very limited research that I did, and with the assistance of a really good friend who helped me design and test all this stuff, that seemed to be the way we ended up going. Okay, so now this is installed, we can plug all this stuff in. I'm not going to plug the battery in until the very end, but we can plug in the home switch. And then I've labeled these just so I can remember where they all go. This is the USB plug. It plugs in there. This is the lux meter. Plugs in there. Camera power. Plugs in there. And the stepper motor plugs in right there. Now these other two, whoops, this is wrong. These other 2 plugs, this is for the OLED and this is for the user panel, and those we won't plug in until we put the case on because they mount onto the case. But other than that, that's the printed circuit board installed. And now there's some exposed pins here and here, and these are how you program this using the Arduino IDE. These are already programmed, but if they weren't, you just plug in your USB adapter cable to these and then upload the program to them. I actually installed this to make it easier to program them. This is just like an extension cable that allows easier plugging in of this board in particular. This one with the USB, this code doesn't really ever need to be changed, so once it's programmed, it's very unlikely this will ever need to be updated. This Arduino, however, controls all the menus and functions and sets all the exposures, and it communicates with this USB one. But this one is where all of the software updates will often be loaded into, and so I want to be able to get to this relatively easily. So I just made this extension, and it just plugs in there, and then when you want to program it, you can pull this wire out of the case and plug in. I'll try to show you that when I'm done. But for now, we'll just leave it dangling out like that. Okay, so we'll put this aside and we will assemble the battery charger circuit. This is not as elegant as I wanted. I originally wanted this circuitry to be on this board, but I didn't know how to design it. So I bought these really cheap USB 2-cell LiPo chargers, tore them apart, soldered my own panel mount micro USB to them, and just left the factory original wire in here for charging. And this way you can just plug in any micro USB through the outside of the case and we get a charger, and I didn't have to spend a ton of time learning how to charge LiPos. It was something I wasn't confident enough in, and the risk was high enough that I just bought something that I knew would work. And because of that, we have these weird little adapters and these this strange little mount. Like I said, it's not super elegant, but it worked and saved me having to worry about a lot of engineering. So we'll push that down into the mount for it, put that into the mount. This wire comes out of the top, and this piece simply clamps down onto all this. Need to make sure the wires are routed properly. Hold that together. These long screws come in all the way through. And a couple of washers. And I'll try to get a close-up on this when I'm done assembling it. Okay, so this is what we have. On the outside you can see micro USB, and the power comes into this board. I just soldered right to the USB tabs, and now we have this little battery adapter that will mount into an access panel on the outside of the robot. Okay, so unfortunately, or fortunately, this charger has to mount on the opposite side of the robot as the battery. So, to route this cable over to here, up this side, and plug it into this, and it just kind of rests right in this little nook here. Okay, so now we've got that built out. Set these fasteners aside. We can build all the pieces into this. This is the arm that sits on the top of the robot and spins around with the camera mounted on it, and the lux meter here. It's a little spirit level. Getting it level is not super critical, but it's always nice to have some type of reference there. Now, one of the things that this had to be able to do is to back the camera up off of the pivot point of the axle, the rotational center, so that we could get the camera lens to, number one, it needed to be adjustable, but it also needed to be able to set the camera at the nodal point of the lens, so as it rotates around we have no parallax. It's really important when you're stitching these spheres together that can be very precise. And the intention with this robot is that you don't have to use the camera or lens that I have picked out. You could use a slightly different lens, which may have a different nodal point, and there needed to be enough adjustment in this to accommodate any reasonable focal length. I'll talk about the camera and the lens that we're using when it's done. But so inside of this we mount a USB plug here to plug into the camera. We have a power plug that goes in here to power the camera, and the lux meter will go into here. So there's some stuff we have to build to kind of do that. We have female USB that just plugs into a circuit board, and this is the circuit board that it plugs into. We'll show this in detail in a few minutes. But lux meter, this is I think a 10 or 12-bit light meter from Adafruit, TSL 2591. We have this adapter that seats in here. We have this diffuser. This is probably not entirely necessary to make this work. However, I needed something to protect the light meter, and these were relatively available and do a really good job. They also diffuse the light so that I don't get very huge spikes if there's like a point source of light shining directly into the sensor. When we were testing, we noticed if you get certain types of light shining directly into the image sensor, you get wacky readings. So this kind of helped prevent some of those weird issues that we were seeing with super bright lights. And when I say super bright, I mean like shining an LED flashlight from like 2 centimeters away, or a laser beam, or some type of focus light source like that. It's very unlikely it ever would have been an issue, but this solved it and provides a lot of protection. So this circuit board, I had to modify it a little from Adafruit. I had to round these corners over so that it could actually fit inside of here and let this thing rotate around to lock. Yeah, had to be very careful not to sand through any of the traces on the PCB. Okay, so we have some super duper tiny screws because this is a very small component. Yeah, so while I fiddle with these, this light meter actually was quite interesting to work with. We ended up doing like some ground truth referencing with some of our professional light meters and some industrial light meters to make sure that we had the we were getting the right lux values, and found that we actually needed to have a multiplier to offset it. Like, I think we're multiplying the values after we put the diffuser on by like 4 or 4.3. And it was surprisingly a linear relationship almost perfectly when we did all the calibration. So we got away with a really simple calibration procedure. It's just a multiplier on the variable that reads this value. So I was anticipating a lot more struggle with that from a programming standpoint and a calibration standpoint. But this light meter from Adafruit is excellent. So it's super easy. Okay, so this can go in here, and there's a threaded insert in the lug. We just need to line that up with this hole and tighten it in. Doesn't need to be super tight. The plastic kind of acts like a lock washer. And then this thing has like 2 little lugs on it that are on the side, and they line up with 2 pieces here, and it just rotates to lock in just like it would on a real light meter. Yeah, so that's the lux meter installed. The next thing we need to install is this USB plug. And let's remove the screws. We'll feed this down through this arm that's hollow. One of the things that I wanted to make sure when I designed this was there's a data bus up here that the lux meter attaches to on this circuit board, and if somebody had some other components that they wanted to introduce into the robot here, you could actually tap into this bus to get data back to the Arduino for processing it. So you can add other things besides a lux meter. We had toyed around with the idea of having some type of spectrometer up here to actually measure the quality of the light and not just the intensity, and we abandoned that pretty quickly when we saw, well, 2 things: how expensive the spectrometers were that we could interface with these Arduinos, and we realized there wasn't really a workflow to work with spectral intensity data in 3D. As fun and as nice as that would be, we couldn't find a way to do it. But I'm sure that other creative people would have some interesting ideas of what data you could collect and use to make this thing even better. snug these a little bit, the bigger bit. Okay. Okay. Now, I made this piece separate from the arm. It could have all probably been built in, but for a few reasons. One, I wanted to be able to get in there. Routing wires is always a nightmare, so I wanted as much room as possible. But the second part was, depending on the camera or the lens you want to use, you may want to change this angle. I angled it up so we had a little bit more overlap at the pole, the north pole, so to speak, of the sphere, and less overlap at the bottom because the tripod is going to be there anyway. And so I cared more about getting data from above the camera than getting data directly below. So I've set this up, I believe that, I think this is 5 or 7 degrees or something. But I wanted to be able to change that easily. And the other thing is, I wanted to be able to pull the camera off and have a really easy adjustment. So we have this this adapter plate that needs to go on. And this is the primary way to set the nodal point. Originally, I was going to set the nodal point and just have holes in here and just design this plate perfectly. But that was not practical. It didn't really work out to try to 3D print over and over and over again, trying to make the nodal point perfect. And if anything ever shifted, then it wouldn't work anyway. So it needed to stay adjustable. So add this tripod plate. And then we have all the adjustment that we could ever need. Plus, if you run out of adjustment on the tripod plate, you can adjust in this slot here to get a little bit more. Right now there's 2 screws in it, so there's not a lot of room for it to slide one direction, but it can slide the other direction, maybe 1.5 centimeters, and you can lock it in with these. So if you had to go down to 1 screw, you could lock it. Really tight. Okay, so there is the camera mount, and this just pops down in there. And once again, I've probably gone way overkill on the fasteners here. It's a big area for improvement in the design. Is there's so many different sizes of fasteners, and you can see how many tools I've had to use. That can all be streamlined so much in another design iteration. But right now there's only 3 of these, and I'm not probably going to build any more. So unless somebody else decides they think this is cool enough to build, it doesn't make much sense to put time into streamlining the mechanical design further, even though there's a lot of opportunity for that. Oh, I forgot a piece. Let's take this apart. Forgot the camera power. This is a fun one too. Much like the nut on the bearing for the axle, this is kind of difficult to get to, and sometimes it goes really fast, sometimes it goes really, really badly. So let's get the nut on here. In, feed the wire down, and it pulls out here. Now this one probably should have been a little longer, but I wanted you have to be able to remove this thing, so I kind of wish this one wire for the lux meter was a little bit longer, but it isn't. But I can still make it work. So now we need to find the nut in here. I'm sorry you're not going to be able to really see this very well, but this nut has to be able to get onto the back of this plug, and there's nowhere to get your fingers. So it's like a claw game at the fair or something. And then I'll try to do a close-up of this in a minute so you can see how much nonsense this is. And slowly try to rotate it with a screwdriver, and I got really lucky. It bit on the threads on my first try. Okay, so this is not an ideal way to attach a fastener, but I'm going to tighten this with a tiny little screwdriver on a nut. Okay, so now I've got some tension on it. I'm just going to push the screwdriver on the high points of the nut. Since this is pretty soft plastic, it stays in place surprisingly well. You can get quite a bit of force on this, but it's also kind of dangerous using a screwdriver like this, so I wouldn't recommend you do it this way. It was perfect for me because I don't mind stabbing myself in the hands. Let's see if I can get a close-up of that. Yeah, so you can see there's the little shiny nut in there, and there's just, I mean, there's nowhere to get your fingers in there to tighten it. And there's what the plug looks like on the outside. Yeah, so let's go back to where we were. So let's put this back in. More twisting. When I left these two holes in the design, in case there was something somebody wanted to route out to like the hot shoe or put a cold shoe on the camera and mount something to that and then get data down through this arm and into the Arduino through the data bus. I never came up with anything, but there are people a lot more clever than I am. Okay, there's the arm. So we cannot put this on until everything else is done though, so we're going to set this aside for now, and we'll come back to it. But the next thing we can do is add this little cam. This is the thing that triggers the home switch. Let's see if we can do a close-up of this thing. And you can see it's really small, and it's got this cam shape in it that rides on this switch here. So it bumps into this, and when this triggers, then the robot knows that's where its home position is. Okay, so I need to get that mounted up, and to do that we need to put these two little screws in. Sorry, you can't really see this super well, so it's kind of tight in here. All right. Pretty good. Now we will adjust this home screw up and down to match that right before we put the case on. But next we can add this printed circuit board. This is what allows this plug to plug this in, and then all the wires can come out to connect to this. yeah, this it just makes it easier to assemble and disassemble. So you can go ahead and plug this connector in, and it just sits on here, right on the top. Hold it in with these four little screws. Great, and then this just sits like this. Let's get a little closer here. So this is the USB to control the camera. This gets our power to the camera to power it. And this is the 3.3 volts, and these two pins on the top end of this are the data bus down to the Arduino. Okay, so that's done. The next thing that we can do, it's getting really close now. This is the user interface panel. So check this thing out. So we've got a menu button, left, right, and go, like execute commands, and this is a power button and a power indicator on this LED, and then the connector on the back. So we need to get this mounted into a plate that screws into the case. And this is the plate that it goes in, and we need 4 screws for that. And it just sits in here like this, and the buttons just poke through. We need to add this button for the big tactile switch for the power at the bottom, and then we've got power, left, right, menu, cycle through the menus, and then start program. So let's screw this down to this panel. And these screws are also threading into brass inserts that are melted into this. So not really needed for strength, but since these are all prototypes, they're being taken apart and reassembled a lot. And the brass threads hold up to repeated use a lot better than ABS or nylon. Which oftentimes, like, you put a screw in once, it will hold, you take it out, the next time it's a little worse, and then maybe the second time it doesn't work at all. Okay, snuggle these screws up. The buttons all still move freely. And so this is basically done. It's got 4 screws that we'll use to mount it to the case when we get to that point. The next thing, this is really the last thing to put screws in except the case. This is where the user display, the OLED, goes. And it just sits on here. We get these fasteners. So let's push the fasteners through these holes because they're undersized on purpose so that they don't fall out when I'm putting the OLED into place. So there's one. Okay, Now the OLED just sits down on those. And then we put these nuts on the back. I have a nut driver, so I'm just going to use a pair of pliers. This don't have to be super tight. Okay, and this is the user panel, and we'll set this aside. We'll pull the wires through to plug that in when we get that far. So the next thing we want to do is plug in these last two bits of the wiring harness. This is for the OLED, so it plugs in to the display plug, and this is the plug for the user interface. And one end plugs into the circuit board, and one end plugs in obviously to the button panel that we just built. Okay, so now all the wires are installed. All the printed circuit boards are set up, they're installed where they need to go. Yeah, it's time to put the case on. So to do that I need to pull all these screws out, which I had installed because there's just there's little slots with nuts in them, and if I leave the screws out, those nuts fall out, and there's some in places where you can't get to after you assemble it. So now I will take all of these screws out. And then we will adjust two things. We're going to adjust the stepper motor belt tension, and we're going to adjust the home switch, and then we're going to put the case on. Okay, those screws are out, so let's get the tension set on the stepper. Let's see, can we slide this back? Yep, okay. So we slide this back. There's not really, I don't have a procedure for getting this at some very specific amount of tension. I just pull on it till the belt's tight, and then snug up these screws. And these as well. Yeah, you can see I should have done these sooner. Okay, let's just double check. Feels pretty good. Now I want to double check that I tightened the set screws, but we need to set the height of this so that it's in line with the gear. So, sorry, there's also there's a few more screws we need to put in. I forgot. There's screws in the drive gear. Those are super important, and I forgot them until now. So what I'm doing now is I'm aligning the drive gear with the screw holes. This is going to be a kind of a pain in the butt. I should have done this a little sooner. Yeah, you can't, I don't know if you can really see that, but let me see if I can get a close up when I get one of these in. Okay. So what I'm doing is putting these screws into this drive gear, and then we'll align the two gears. Let me get these in, and then we'll align them. Okay, so that's installed. The next thing we need to do is make it so that this tooth profile is aligned with the nylon tooth profile, and we'll do that by raising or lowering this this metal gear here. Tighten one of the set screws on the flat. I'll spin this a few times. Yep, it's tracking. Okay. Okay, now the next thing we need to calibrate is this home switch. So we will, yep, those are loose. We will bring the cam around until that roller is right on top of the center of it. And then lower this. And then bring it up until you hear it click, and then maybe like less than a millimeter more. Oh. Okay. So then I usually tighten this, and I'll check it a few times, because when you tighten these fasteners on this stuff, it moves around, and this is precise enough that you need to double check it. Okay, so let me see if I can get you a better view of this. Okay, so you can see now, if finding the exact home position was critical, this wouldn't really be a great way to do it, but we just wanted to kind of start in the same spot every time. The other thing we wanted to be able to do was eventually add like a time-lapse mode, and you may want to be able to reference a point, and this is consistent enough that it will get you within less than a degree. It's not, it will get you less than a degree relative to itself, but there's no absolute position. Like, we can't zero to the exact same point every single time, but it calibrates itself every time it runs anyway, so it's not a big deal. Okay, so let's do the fun thing, which is let's close it all up. So this is the case. We've got to kind of work this thing down on here. Get all these wires through there, not pinch anything. Yeah, so the first thing I generally do is, since this has a really long wire on it, I just push this through the hole that it's going to go into. So it goes in there, and then I can start to put this on here. I can put the display cable, the user interface cable, and the programming cable, kind of stuff them up in here while I slide this down. And then I can start to pull them out. This one's easiest because it's the longest. It can come way out. This one comes out up here. This one comes out here. Now before we button this up, we want to plug the battery in. So I'm going to plug the battery in now. And continue to slide this down. Make sure that these wires are sticking out where they need to go, because it's easy to get them pinched in between parts because everything fits so tight. Okay, so now the case is on. I did a little bit of a mistake here. Got these twisted up. Okay, so this wire we can kind of try to hide away. We're not going to need it until we program this thing, and this one's already programmed. So I've just kind of tucked it away in there. This can be plugged into here, the user panel plug, and the display. And of course the polarity matters on all these, but if you made it this far putting one together, you'll be able to figure the polarity out. If not, let me know, I'll help you. Okay, so all the pieces are here except the camera arm is not plugged in. However, we can try to turn this on and see if we get it to run. No. Okay. This is usually one of these things is plugged in upside down. No. Huh. I get to do some troubleshooting. I don't think all this needs to be plugged in. Just in case. This is why I didn't want to screw all this stuff together before I tried it out. I'll be back. think I may have just plugged in the cable backward for the OLED. Just double check everything. So we've got okay. Yep, okay. So I had this cable flipped backward, but now you can see when we turn it on, it runs. Okay, so let's put all this stuff in, get this arm bolted down, and demonstrate it all working. So these are pretty self-explanatory how these panels all fit in. It's just screws. I like to try to align this with the cam switch. Doesn't really matter a whole lot, but yeah, just seems to make more sense logically. Now I'm going to add some washers as spacers in here. I was getting some binding up between the arm and this case on this particular one, this particular prototype. So rather than redesigning some parts to add more clearance or spending forever sanding some clearance in, I rubbed some graphite lubricant on here and some graphite lubricant on the arm, and then I'll add these washers to space it up. And that got rid of the problem entirely, so at least the last time I tested this one it did. I'm just lining up the washers now, so I've just kind of set them resting on top of there, and then they'll line up with the screws here, which I'm gonna put in all these holes. These are also way overkill, but I like the way that they look. These big, sturdy looking industrial screws just made it look nicer. Yeah, so plug in the camera power, plug in the USB, make sure that everything is plugged in facing the right way, because some of these plugs are not polarity protected. Okay, and then get these wires kind of packaged up so they spiral up into here, and gently set this down onto the washers, and get some of the bolts started. First one's always the most difficult. Okay, try this one. Interesting. I've actually modified this part since the last time I assembled it, and I think that's causing some trouble. Okay, I'm going to pause here and I'm going to go, I'm going to do a touch-up on this. So what happened is I melted these brass inserts in a little further, and they've displaced some material. And I think some of these are preventing the screws from starting, so I'm just going to go in here and with a chamfer bit in my drill and chamfer the displaced material away. Hopefully that will clear it up enough to seat these screws a little easier, bolts. This isn't ideal because this is going to put some plastic down inside the robot, but this is all non-conductive. It's like nylon, so it shouldn't be a problem. I'm just cleaning up some of the material from this extra chamfering that I just did, or countersinking. I was thinking about removing this part, but I think I'll leave this in the assembly video because I mean this is just how these things always go when you're putting these prototypes together. I've had this thing together before, and then last time I put it together, I wanted to make this small change and then hadn't tested it yet. So I think I'll leave it in there. These things don't usually go very smoothly, so I don't need to show it going super smoothly. This thing I'm screwing on now is the access cover to the stepper motor. Can't really do much through here, but it has proven useful for for troubleshooting. Like, oh, the stepper motor came loose, or the pulley set screw came off. And doing testing, I don't always tighten things up very well, so it's nice to not have to pull everything off to check what the motor is doing. Okay, next thing, let's put the battery charging panel in here. And more screws. Okay, all the panels are on. Let's put the arm back on and hopefully it fits better this time. Camera power, USB, and lux meter. Okay, and see, our home switch is basically lined up with the screen, so I'll line the light meter up with that. And oh, forgot one thing. Forgot my spacers. I'm just lining the washers back up and make sure nothing's going to get pinched up in there. Okay, way better. Before we tighten any of these, I want to make sure they all get some engagement, or those washers that I slipped in there will be pinched so tight we'll never get everything lined up. So these two are a problem. The way that this is designed is really foolish. I don't have any way to get an Allen wrench in here, so I've had to make this one and cut it off. And there's not that much room to maneuver the tool, so these last two make me not very excited about my design here. I debated on making some holes through the arm up here that the wrench could go through. Aesthetically, I didn't like that. And since I don't have to build these all day, every day, I just left it. This is another one of many areas where this design could be improved. I like to have these 6 bolts pretty tight. You can hear it on the brass there. Because this is what's holding the camera on, and I don't want it wiggling any more than it already is going to from being all made out of plastic. So there we go. Okay, so the next thing, we have a USB cable. We can plug it in here. And we have the battery adapter for the camera. So let's get the camera off the other robot. Now, I guess before I set this up, I should finish bolting the case on. But while I do this, I'll talk about the camera a little bit. One thing that we wanted to make sure for this, that you didn't have to hack the firmware. You can have like Magic Lantern firmware if you want, but we didn't want to rely on that. We also wanted, or I wanted, the camera to be able to come off here and be used for other things. So like if you're on a film set, shooting an HDRI may be one of 50 things that you need your camera for, and why carry around 2 or 3 of these big heavy cameras? You can just have this one, you can shoot any of the reference that you need. Yeah, and this way you can take this camera off and use it for other things. It's not dedicated to just shooting HDRI spheres. And the Arduino interfaces with it using the hex code for the camera, so it operates the camera just like any Canon accessory would. The other thing that I wanted was to not have a separate battery. I wanted the camera, you can power it with its own battery, but I also wanted, if you wanted to just have this as a dedicated HDRI sphere tool, then you could do that. Okay. So, I have already set this plate up to match the nodal point of this lens. This is a Canon 8 to 15 millimeter EF mount. It's a Canon 5D Mark II. You need to leave it set to 8 millimeters, and usually I set the focus to infinity because that's anything more than a meter away from the lens will be in focus. Not that it matters a whole lot for these, but since this plate is already set up for this camera and this robot for the nodal point, I'm not going to go into how to do that. It's a whole procedure for finding the nodal point of your camera. I'm sure there's a ton of videos about it, but for this you just line these plates up. Let me get this tight, since it hasn't been set before. Okay, so you just line these plates up, and it's at the nodal point for this setup. One thing that I probably should do is put this battery adapter in. And all I did to make this was take a aftermarket battery plug and just soldered this to it. I can shoot a picture manually. So let's turn it on here, and we can see we got the logo for my friend's company. The default settings are 11 exposures per stop, per location that it's going to position itself into. And it's going to do 1 full stop between exposures. You can change all these, obviously. And then a delay, so like if you're in a room you want to get out of the way, like you're foolish and wearing a bright red shirt, or you just want to make sure you're far away from the camera, you can make a delay in here. And when everything is set up, let's make it not do very many shots just so we can get through the whole cycle quickly. So we'll do three exposures per stop, and we'll do one full stop between settings, and we'll hit go, and you can see it's going to do our countdown. I'm going to hold on to this since it's not mounted to a tripod. So it's doing a countdown. Now it's going to go find a home position. Found home. It's going to do a lux reading, which it's not getting any values. I'll troubleshoot that in a minute. They probably just have something plugged in wrong. Gave us an error, but it's still going to continue. Okay, so now we're getting, you can see, oh, focus. You can see it's changing, whoops. It's setting up the camera for each shot. And that's done based on a lookup table in the camera that is using the lux reading, which in this case got an error because I plugged it in wrong. And there's 5 different exposure ranges, from like fully bright in the sun to like a candlelit room, and this will set the exposure properly for all of those. And we get a extra life when it completes. That is the Orbot, and unfortunate that the lux meter still has that small issue, but I'm not going to make you watch me take this all apart and fix that. Yeah, so you can see then if you're doing any VFX work on set and you want your 5D to go shoot crop references or any other stuff that you want, you just take it off, swap the lenses, stuff this back in your kit, and go on about your day until you need another HDRI. This will sit on a table flat like this without tipping over. It's really designed to be on a tripod. I usually put one of these leveling heads underneath it on the tripod, just so I can get it kind of flat. But yeah, it's proven to be pretty reliable, and it shoots an HDRI sphere super quick. So if you decide you want to build one of these and you manage to get all of the parts printed, I have some extra circuit boards. If you've made it this far through the video and you want to build one of these, if you get in touch with me through YouTube, show me what you've built, or I can help you along the way. I will send you some of the extra circuit boards so you don't have to have them made. They already have all the components and everything soldered onto them. It'll save you a few $100s and a lot of effort in assembling them. So yeah, if you think this could be a useful tool for you, please reach out to me. I would love to get some feedback about all the stuff that's not great, and to help you make one maybe that's even better than the ones that I've built. So if you've made it all the way to here, I'm super excited. So I appreciate your time, and hopefully I hear from you.